Hello students, the purpose of this video will be to assist you with filling out the table for your second lab, the liquid limit and the plastic limit lab. I've provided you with some sample data from a previous example of this lab being carried out. You can see it right here on your screen. You can also find it under your Lab 2 folder on Blackboard. And this is what it looks like. This is what the table looks like that I uploaded for you as a sample. In order to carry out your lab, and indeed also to follow along with this example, you will require some form of writing utensil, some form of a calculator, like this, and you'll also require this information that I provided to you, or equivalent formulas which you might find based on the material courses you've already taken. If you have any issues, feel free to contact me about them. Now back to this data. The idea is that you'll be able to fill out this table to get all the information necessary so that in the end you can produce something that looks like this. Okay, with all the content filled out, the graph in there, and the values for the liquid limit, the plastic limit, and the PI all calculated, so you can write out your report. Let's get at it. The first thing you want to make sure you do is that you fill in the dry weight and container. These are the weights of the material that's been dried overnight that I provided for you. Okay, so I'll be doing that. I believe that I actually provided this for you for your data, but I'm going to do it nonetheless. Similarly, I'm also going to fill in the dry weights for the liquid limit test. So at this point, we actually have on the screen what I've provided to you in terms of the data, the equivalent data, I guess, for the lab for you to prepare and submit. That is, you have the wet weights and containers for the plastic limit, the dry weights, and the weights of each container. Your numbers might look different, but basically these rows should be filled in. Similarly, for the liquid limit, you would have the wet and dry weights plus containers, as well as the weights of each container. Now together, we're going to go through how to fill out each one of these rows so that you have a completed table for both the liquid limit and the plastic limit. We're going to start with the plastic limit, sample 1. The weight of the water is simply the wet weight plus container minus the dry weight plus container, right? That kind of makes sense. The wet sample and its container minus the dry sample and its container is going to be the amount of water that evaporated in the oven overnight. So in this case, 3.52 minus 2.96. So what I'm going to do now is I'm just going to fill in all the wet weights for all these samples and do the same thing for the liquid limit test. And voila, this is where we are right now. We calculated the amount of water that was in each one of these samples. Again, the amount of water, or the weight of water, is equal to the wet weight plus container minus the dry weight plus container for both the plastic limit and the liquid limit. Let's now move on to calculating what the dry weight of each sample is, okay, for both the plastic limit and the liquid limit. The dry weight for each sample is equal to the dry weight plus container minus the weight of the container, which makes sense, right? If I have the weight of the dry sample plus the container, and I subtract the weight of the container from that, I'm going to get the dry weight of the sample. So in this case, 2.96 minus 1.33. And I'm going to fill in all the other ones for both the plastic limit and the liquid limit as follows. And voila! Clearly, I'm doing this by hand with a pencil. However, once you've done the same, you will then transfer it to your Excel spreadsheet so that it looks a little bit more professional, say like this. Now that I've filled out everything except for the water content rows for both the plastic limit and the liquid limit, I'm ready to do some of the more difficult calculation. Luckily for us, the more difficult calculation is not that hard at all. The water content as a percentage for a soil sample is easily calculated All you have to do is either remember the formula that you learned when you took your construction material courses with your professor, or go back to these formulas that I provided to you, and you will find that the water content is right here. So the water content as a percentage is equal to the weight of water in that sample divided by the dry weight of soil times 100. So let's apply that to our lab. This water content then is equal to the weight of water, which we have, divided by the dry weight of the sample, which we have, times 100. So I'll do the first one. In this case, it's that amount there, weight of water, 0.56, divided by the weight of the soil, that there, which is 1.63, all times 100. I'm now going to fill in all the other water contents. And voila! This is a good point for me to remind you of some things not to do that would prevent you from achieving full marks. Quickly, notice how in each of these tables the units have been provided to you. Grams, percent, grams, percent. That means that you don't have to include those units in your tables, whether grams or percent. It's redundant and would result in you losing marks. So in the interest of being thorough, I'm going to make it obvious. If you were to write this as a percent, don't. It is already described as a percent. You would lose unnecessary marks. We are now actually ready to calculate the liquid limit, the plastic limit, and the PI index. Let's do first the plastic limit.